Hello everyone. In this video, we will be discussing the continuation of the module 2. That is, already in video 1, we had a discussion on what is gear, classification of gears, the materials of gears, its advantages, disadvantages over the flat belt drives and chain sprockets. All those things we have discussed, but in this video we will be discussing a few more informations about the gears, that is standard systems of gears, the lubrication of gears, gear tooth failure modes, and very importantly the nomenclature. So all these things we will be discussing in this video. It is very important video, because if you are not viewing this video mean, then it will be very easy for you. I mean, it will be very difficult for you to understand whether the procedure or the concepts or whatever thing. So first, we will discuss about standard systems of gear tooth. That is, we can say like these standard systems means whenever we solve any problems in designs after finalizing the dimensions, we will be going with the standard values which is recommended by various reputed organizations, which is present in our design data handbook. Similarly, for the gear tooth also, where we will be designing after designing, and even while designing also we will be following certain parameters, and we can call it as a a certain instructions which was guided by the various organizations, which is mainly given their the standard values for the improvement of the gear designs. So the gear tooth geometry is determined primarily by pitch, depth, and pressure angle. This is the very important the three parameters we need to remember, particularly when we speak about the gear tooth. So we know like the pitch, the standard pitch are usually the whole numbers when measured as the diametrical pitch, capital P, the ratio of the number of teeth to the pitch diameter in inches. So actually in the nomenclature portions, where I'll be discussing in detail about what is the pitch and other things. And moving to the next one, the coarse pitch gearing, which has the teeth are larger than 20 diametrical pitch, so usually 0.5 to 19.99. Then moving to the next one, the lubrication of gears, where the lubricant is very important, because here the gear itself is nothing but the tooth wheel, isn't it? And even we will be using the the metallic chain, so for the operation, so lubrication plays a very important role. If we are not providing the required amount of the lubrication, that too on the right time, that immediately leads to the failure, and that particular, and further it leads to the wear and tear, and immediate failure will take place. So lubrication is very an important a thing we need to follow, particularly when we speak about the gear operations. So usually the kind of lubricant what is used in gears is, it is usually mixed with compressed air to form an oil mist. So here the air should be compressed, and that should be mixed with the proper lubricant oil. The lubricant oil again, the based on the application, the oil will be selected, and once this lubricant oil and the compressed air is mixed, and that will be sprayed against the contact regions of the gears, and this is especially suited for high speed gearing applications. And examples of the gears where this is followed is oil tank, pump, filter, piping, and other devices were needed in the course of the oil lubrication system compulsorily, because we cannot go with this manual spraying bottles and other things, because all these things are very mandatory for the lubrications of gears, particularly this setup. And moving to the next one, gear tooth failure modes. So previously we discussed like the standard like the things to be followed, like the pitch, the pressure angle, all those things we have followed. But still, what are the the gear tooth failure modes? Here you can able to see that it is listed out. So the metal gears fail for numerous reasons. Some in part independent from the gears themselves. So the good news is that there are only 5 common failure modes. So if you focus on those things, and as much as possible we try to avoid the failure. So first one is nothing but the bending fatigue. As we know, like gears, it is something like it usually goes under the repeated loads. So fatigue will be there, and the material will go under the tiredness. So the more the frequent chances of the gear tooth failure will be the bending fatigue, that can be avoided like after leaving certain break after the operation, like some cycles. And next one is nothing but pitting and micro pitting. Both pitting and micro pitting can be avoided to certain extent. Then next one is the scuffing, and last one is nothing but the wear. So all this is related to the kind of material what we are using for the manufacturing of gear, and the type of lubricant, and the duration. So all those things plays a very important role. So if we follow everything properly, then we can avoid the failure as much as possible. And here the bending fatigue failure is the result of cyclic bending stresses at the tooth root. So now we shall move to the nomenclature of the gears. So you can able to see I have taken one particular example where starting from the green color reference line we will be calling as the addendum circle, and similarly this cycle you can able to see like the pale color dotted line circle is nothing but a dedendum circle, and we have here something called clearance circle. You can able to understand what you mean by clearance circle, and addendum circle is nothing but the top of the gear tooth. And we have something very important thing. I'm talking about this line, that is nothing but the pitch circle. Pitch circle is nothing but exactly the mean of the tooth. So the mean of the tooth. So from the pitch circle to the top of the top land, the distance we'll be calling it as addendum. And similarly from the pitch circle to the bottom of this one, the clearance, what is that? The dedendum circle will be calling as a dedendum. And we have a hole depth, working depth, tooth thickness, circular pitch. You can able to see the distance from this end to this end we will be calling as a circular pitch. And pitch circle, and face is there. This is face, and this is flank, and this is the top land, this is the bottom land. I will see in detail. So pitch circle, it is a theoretical circle upon which all calculations are usually based, and it is an imaginary circle that rolls with out that rolls without slipping with the pitch circle of your mating gear. So further pitch circles of your mating gears are tangent to each other, and you can able to see this here. I'm just moving my cursor to the pitch circle. So it is basically a theoretical circle, so upon which all the calculation like addendum circle or dedendum circle or like working depth or hole depth, whatever thing. And we cannot see this pitch circle in the practical conditions because it is an imaginary circle. And even these pitch circles we cannot, since it is an imaginary circle, we cannot say like it will slip out, and all those things will not be there. And even these pitch circles of the mating gears which is a tangent to each other. And next one is nothing but the pitch circle diameter. So pitch circle diameter, which is nothing but the pitch circle diameter is the diameter of the pitch circle. You can able to see, like if you use the gear mix, what is the diameter? That diameter is nothing but pitch circle diameter, and it is usually denoted by small d. In the next video, we will discuss the remaining things in detail. Thank you.